in this lesson, so we'll try to understand the data center journey. Basically, we'll try to understand how the data centers are being transformed in the last 20-25 years of time, and how the data centers are today, and what are we calling them. So in the last lesson, we understood about data center. So what is a data center? So data center is basically an office space or a room aside, basically, which consists of server racks and which holds basically servers, the storage devices, network devices, then like firewalls, tape libraries, then running various applications, operating systems, and data. Basically a secure place in the an office or somewhere, basically, which can secure the servers, which has the very good connectivity, power backups, generators. Okay, basically to ensure that the servers and applications are running on a maximum time or highly available. But these data centers are being transformed like anything in the last 20 years of time. Okay, but we'll talk at a very level. Okay, so we see something today, cloud computing, or basically clouds. So initially we were calling it as a physical data centers, a physical data center. Then slowly a physical data centers are being transformed into something called as an virtual data centers, virtual data centers. And the virtual data centers are being transformed into called as an cloud data centers, cloud data centers. We'll try to understand what makes a difference between all these things. So, and what happens in the initial data centers, I would say called as a first generation or a data centers, or we can say called as the initial data centers. So in the initial data centers, so we used to have a physical server. There's a physical server. So I would say a physical server. So on top of this physical server, so we install one operating system. So like a Windows Server 2016, something like I would say call it as an operating system. So on top of this Windows Server operating system, so we install an applications. So these applications could be like an SQL server, could be like an applications like Exchange server or SAP or Oracle apps. Like there are so many kind of an applications. So what happens here is on every physical server, so we have only one operating system running. On top of that, one application running. So each and everything is a physical component, and the servers gets connected to a physical network switch, which is a network switch, and storage devices. They get connected to the storage devices. So what happens in the initial data centers is so one server, one operating system, one application. So now if I have a physical server goes down, then I have this application will go down. So what were the challenge there is okay, if the application goes down, there is a business impact. So in order to make the application highly available, we say there are two physical servers, each server running independent operating system and running a same application on two physical servers. So now what happens is in one application, in order to make highly available, we started running two servers, basically in order to maintain the availability of the application. So that way what happened is in the data centers, in the initial data centers, first is that the server configurations were very less. So we say that two processors with 8 GB RAM, a four processors with 16 GB RAM, like a small form factor servers configurations. But in the data center, there are too many servers. So too many physical servers, I would say. So why one application required two servers in order to ensure they're highly available? Now that way what happens is then they consumes lot of space in the data center. Because now only for one application I'm talking about two servers. If you have a 60, 70 plus applications, then imagine that roughly around you have 300 plus servers running in the data center. And in order to hold that, keep that 300 physical servers in the data center, you need, a lot of basically space in the data center. And because of this too many number of physical servers, basically generates a lot of heat. And because of that, basically the high demand or basically high requirement for cooling, which is basically air conditioners. So we need to run these air conditioners because as there are too many number of physical servers running in the data center, and as they generate a lot of heat, so in order to maintain the temperatures in the data center, so there is a requirement for high cooling requirements and where we run ACs. So as basically too many number of servers, they consume a lot of power, which in turn basically has I would say called as an high electricity bills. Physical servers, because we are running physical servers, they consume a lot of power. Now, as they consume power, we see that the electricity bills are high. So in the first generation data centers, from a perspective of basically servers, the data centers, they consume a lot of space and there are basically a lot of cooling requirements in the data center and huge electricity bills. From a perspective of a maintenance, when you talk from a maintenance, a physical presence is required. A lot of physical presence in terms of maintenance. It means that server goes down. We have to go to the data center. Then we have to check the cables. We have to check the power cables. Then see what is the reason and a lot of other things, which is basically physical presence of a person is required. And a lot of manual efforts required in maintaining these data centers. So what is happening in a lot of manual efforts is then, if I need to bring one server up and running in the data center, so I have to basically go into the data center and sit for a couple of hours or days to bring the server up and running in the data centers. And to perform a lot of maintenance activities like upgrading a patching or doing an firmware upgradations or many things, and people have to go to the data center and do a lot of maintenance. So that's where we see the initial data centers are being basically or evolved, basically I would say called as a lot of manual efforts and a lot of power consumptions and other things. So slowly what happened is we moved something into something called as a second generation data centers. A second generation data centers, where we call virtual data centers, virtual data centers. So virtual data centers came into picture. What are these basically virtual data centers now? So virtualization came into picture. There is a technology called as virtualization, as everybody might have heard about a virtualization. So there's a new technology basically, which is called as a green computing. People used to call as a green computing, okay, extensively in the year of 2007, 2008, and 2009, basically, which has moved from 2007 to 2014, 15, we used to call a virtualization and green computing. So what is this virtualization now? Virtualization is basically a software. So what benefits this brought is so I have a physical server. So in the physical server, so instead of deploying the operating system on a physical server, we started installing the virtualization software. Virtualization software. Maybe you might have heard about something called as a VMware virtualization. Okay. So we started installing a virtualization software on top of this particular ones. Now, what is this virtualization software will do? So this virtualization software, this virtualization basically it is a software. A virtualization technology is basically a software which allows us to create a virtual processor which functions like a physical processor, but it is a virtual processor. It creates a virtual memory which functions like a physical memory, which allows us to create a virtual hard disk which functions like a physical hard disk, and like a network adapter which functions like a physical adapter, a graphics adapter which functions like a physical adapter, an USB adapter which functions like a physical adapter, etc., etc. So what this virtualization software is bought is they try to simulate, or I would say called as emulate, the physical hardware as a software. However, the virtual processor will consume the physical processor, but we call it as a virtual processor. It's a software-based processor. Similarly, the virtual memory will consume the physical memory, but we call it as a virtual memory. The virtual hard disk, which we called as a virtual hard disk, which basically uses the physical hard disk, the storage capacities. Similarly, the virtual network adapter will use the physical adapter. The virtual graphics adapter will use the physical graphics adapter. So this software, whatever the virtualization software, started creating the virtual devices, which will exactly works like a physical devices. Now it's not only creating these virtual devices, so it created something called as a virtual machine. It started allowing us to create called as virtual machines. So what is the advantage of this one now? A virtual machine. This virtual machine is like a physical machine. It's like a physical server. So this virtual machine will have all the virtual hardware which required to run any operating system or applications. So by having the virtual processor, a memory, hard disk, network adapters, graphics adapter, USB adapters, and everything, it is creating a virtual machine. Now, what is the advantage of virtual machine? The virtual machine will have its own hardware. and the virtual machine will have its own operating system and applications. So by creating a virtual hardware, we are assembling it, the virtual hardware, and we are calling that as a virtual machine. And this virtualization software is allowing us to install an operating system like Windows, Linux, okay, a Mac, Solaris into this particular into these virtual machines. On top of that, it allows us to install applications like a SQL, an Exchange, or an SAP, Oracle, or whatever we call this in Salesforce kind of an application which we can install. So that's the advantage of virtualization. Now, what is the other advantages now? So by having the virtualization software installed in the physical server, I create multiple virtual machines. We create called as an multiple virtual machines. Now this is one virtual machine, and this is another virtual machine. This is another virtual machine. Now, what happened here now? A virtual machine 1, virtual machine 2, and virtual machine 3. So it started having a different virtual machines. The physical server is only one. So on top of the physical server, we deployed a virtualization software like VMware vSphere. Now that software allows us to create multiple virtual machines, which exactly functions like a physical machines. Now, what is the virtual machine? It's a virtual hardware. We'll have an operating system, we'll have an applications. Now, this virtual machine has a OS. On top of that, you can have your own applications, apps. So now each and every virtual machine can have its own operating system and applications. Now, what happens here now? By having a one physical server, I'm running 3 different virtual machines with the 3 different operating systems and 3 different applications. So what is the advantage of running this one? So in a physical data center, have a physical server running Windows Server 2016 and running a SQL application. So on the physical server, I have a 4 processors with 16 GB RAM and I would say 512 GB of hard disk space. Now this physical capacity is dedicated to this operating system and applications. Whether they use it, whether they don't use it, it's always available to these applications. It means that if this application is not using the physical capacity, we are wasting the resources. We have invested a lot of money on this physical server, but we are not able to use it. Apart from that, it is generating a lot of power and other maintenance. Now, what is the advantage of virtualization now? On the same physical server, having a 4 processors with a 16 GB RAM, with a 512 GB of hard disk space, I can create 3 virtual machines or many more virtual machines. What is the advantage of that now? Instead of 1 applications, 3 applications can share the physical resources. 3 operating systems can share the physical resources. It means that as long as the physical capacity is available, I can create another virtual machine and I can use the existing capacity. So my physical resources are not going waste. My physical capacity is not sitting idle. The first thing is in the advantages of that, what we call as in the advantages of virtualization is in a better utilization of hardware resources. Hardware resources. And create multiple virtual machines or run multiple applications on a single physical server. Now, what is the other advantage now? Earlier, in order to run 3 applications, we are having a 3 physical servers. Investment is high. You are investing on 3 physical servers, and they are generating a lot of heat, and they are consuming a lot of power, electricity. It means that now, what happens now? So you are basically reduce electricity bills and less AC cooling requirements, and less space requirements. So in a physical server data center, you might need 1,000 square feet, like in a 20 server racks, to hold and 200 physical servers. But now in a virtual data center, I don't need 200 physical servers or 100 physical servers. By having a 10 physical servers, I can run 300 applications or 200 virtual machines. Now, what happens with that? A lot of physical space requirements have come down. So that's where we would see called as a less space, a data center space, which is required in order to run. It means that we can run more number of applications in the less space with reduction in terms of basically power, electricity, cooling requirements, and everything. What is the other advantage of other things? From a perspective of maintenance, what I would see called as an faster deployment of servers, VMs. That is nothing but a servers. Now, what happens in a physical data center? You need to procure a physical server from a hardware vendor. The hardware vendor has to deliver that server to your data center. Then we need to set up that server in the server rack, assemble it, then connect the power cables, then install operating system. And that would take, and I would say that 45 days to 60 days of time, the whole cycle of basically procuring it, getting delivered into the data center and preparing it, readiness and everything. What happens in the virtual data center? If I need a new server, as it is a software, I simply go into the virtualization software and create a virtual machine. In less than 15 minutes of time, I have another server with an applications running in the data center, because I don't need to buy the physical server. As long as there is a capacity available on the physical server, I go and basically create a virtual machine in this case. So it means that a faster deployment of basically virtual servers in the data center. And easy high availability. And other advantage which came with this, what we called as it has basically increased the high availability. So what is that high availability now? So if I do a physical server maintenance, this application will go down. In virtualization, what happens is, if I'm bringing this physical server down, these virtual machines can be migrated to the another server without having any kind of a downtime. It means zero downtime. At regular intervals of time, we need to do a firmware upgradation on the physical servers, and virtualization software update has to be done. But during the part of this maintenance, we don't see any kind of a downtime to your applications. That way, it is giving you called as an improve or basically increase in the availability, and we call it as a more high availability compared to your physical data centers. And basically, we can save a lot of cost savings, okay, because it generates less power, consumes less number of servers, which in turn electricity bill savings, space savings, and maintenance savings, like all these things which we would see that benefits. So that's where we see that virtual data centers came into picture, wherein in the virtual data centers, in the second generation virtual data centers. What happened here now? So this is a data center. So within the data centers, we have a physical servers. You have a physical servers, like many physical servers. On top of that, you have a virtual machines running on that case. So on top of the physical server, you are installing a virtualization software. And on top of that, basically you are running multiple virtual machines. Like in one server, you can even create 200 virtual machines, 300 virtual machines, as long as you have the capacity available. As long as you have the capacity available. Now what happened here now? Like this, you can have n number of virtual machines running by using the virtualization software. Now it's not only servers. Network got virtualized, storage got virtualized, because it's creating a virtual network adapter, it's creating a virtual switch, it is creating a virtual firewall. Everything got virtualized. That's where the faster deployment in the data centers have come up. And everybody, most of the, I would say that, and 99% of the customers started using the virtualization, and they converted their physical data center to virtual data centers. But however, it doesn't eliminate your physical servers, but still we need the physical devices. Physical servers are required, physical switches are required, but the amount of servers, like in the number of servers required in the data centers are less when we go with the virtual data centers. The number of physical switches which is required got reduced. Okay, and easy maintenance and easy management has become better. That's where people basically called as and started using virtualization. So that's where we would see called as in the virtual data centers. What? Now, what else now? Still, we need something more. Now, what benefits giving virtualization? Everything is software. The virtual data centers, the virtual machines, the virtual switch, virtual firewall, everything is basically virtualized. Because it is a software based, we can just initiate and right click and create a new virtual machine and going to create a new virtual machine. Now, slowly, industry is moved into something called as an cloud data centers. Cloud data centers. So what are these cloud data centers now? Today, we are extensively using terminology called as in clouds, cloud. Now, the same virtual data centers, it's the same data centers, but within the data center, they've added one layer called as a self-service layer. What is the self-service layer? So before we go into these technicalities of that, we'll take a simple example. So once, maybe 5 or 6 years before, if you want to book a cab, so you have to call a taxi vendor and say that I need a cab. So I have to go from my house to the airport. If you want to book a ticket, you have to go to a ticket vendor. Then you ask him that I need a ticket from Hyderabad to Bangalore. Something which is basically we have to go and depend on someone else. Now today, what is happening now? Self-service. What is that self-service? I open a Ola or a Uber app from my mobile. I choose the source, I choose the destination, and I choose the type of the service I needed. Then I book myself. It means that now I don't need to depend on anybody else to book a cab. That is a self-service. It means that as a consumer, I book my cab. Similarly, when I need a ticket from Hyderabad to Pune or Bangalore, so I go to the app from a mobile, like a Redbus or an Abibus or some kind of an app. Then I choose my source and destination. Then I book my bus and select the seat and book my bus. Now what happens now? I, as a customer, I'm able to book my ticket itself. That is called as a self-service. Let's go to the banking. If you go back to 7 or 8 years before, if you want to transfer money to your friend or someone else, we have to go to the bank and we have to give a check and we should ask him to basically transfer money to the another bank account. Today, what is happening? I just have an app on mobile. I'm using a phone pay or an GP or some kind of an apps, banking apps, and I'm just initiating a transfer on myself. That is called as a self-service. But do I know what is banking? I don't know what is my banking. I don't know what is a credit, what is a debit. What I all know, how to use the app, how to transfer money, how do I check whether I received my bank or not, and how do I know how to operate the application and just give the input. Now, when I want to book a ticket, I just need to provide a source. I need to provide a destination, and whether I need a sleeper or time or this thing, I just need to provide a few inputs. Then I get the basic ticket. That is called as a self-service. Now, what happened in the data centers now? Today, they're calling it as a self-service data centers. We call it as a self-service layer. We call it as bought into the data center. So on top of the virtual data centers, they bought something called as a self-service. What is that self-service now? I want a virtual machine. Now, earlier, I need to raise a request to the virtualization administrator, and he creates a virtual machine and give the details to me. Just like as I said, if I want to transfer money from my bank to another account, I have to go to the bank, then I have to raise a request. Similarly, here in virtualization, if I want a virtual machine, I have to send a request to a virtualization administrator, say that I need a virtual machine, then he creates and send it to me. I have to wait until the virtualization administrator creates. But with the cloud data centers, what is happening with the self-service? I don't need to depend on anybody else. This is a self-service portal, an app, an application, wherein as a customer, I can interact with the data center. I don't need to depend on anybody else. I can depend directly on a cloud, a data center. So what advantage now? I want a virtual machine to deploy an application. I simply go to the cloud data center, I set up my account. Then I choose the capacity of the VM, which is required, like a 2 process with a 4 GB RAM, with an 100 GB of hard disk space with a Windows Server 2012. Then say create, then it creates a VM. In less than 10 minutes of time, I have a virtual machine up and running in the data center, and I don't need to depend on anybody else. That is the self-service now, self-service. So that is the where we are calling it as a cloud. So I can create a virtual network, I create a virtual storage, I create a virtual machine, I deploy my applications, everything into the cloud data center without depending on anybody else. I really don't know what happens in the backend. How the virtual machine gets created here, I don't know. All what I need, I know is I interact with the self-service portal, and I request that I need a virtual machine with a 2 processors, with an 8 GB RAM, with this capacity, and just say create. Then it creates a virtual machine and give it to me that, hey, your machine is up and running in the data center, and this is your IP address or a name to access this particular virtual machine. That has become a self-service. That is what we're calling it as a cloud. So what does that mean? Compute on the internet. Compute on the internet. So over the internet, I'm requesting for a virtual machine which is going to run in the cloud data centers. That's where today we are seeing something called as an Azure cloud, AWS cloud, Google cloud, Oracle cloud, like many cloud providers. What are these? They are cloud data centers. They have set up data centers with virtualized and a self-service portal so that customers can use these data centers to create their own resources like virtual machines, run their applications and everything. That's the journey of basically called as a data centers. Today, we are seeing called as a cloud data centers. Okay. So that's the advantage of cloud data centers is an faster deployment of resources. I don't need physical infrastructure or a physical space or anything else. I just go to a cloud data center, set up my account, then basically create my own resources. In less than, I would say, half an hour of time, I have my application and resources up and running on the internet. That's how the data centers got evolved. And today we are all seeing called as a cloud data centers. Okay. So in the next lesson, we'll try to understand the Azure cloud overview, that what is Azure cloud. So now you understood about what exactly mean by a cloud data center. Now we'll try to understand from an Azure what exactly they are trying to provide.